Okay, so let's continue with 4.2, and now let's consider the graph of secant. So let's recall. See where the top of the page is there. So recall that secant of theta is the reciprocal to s's and c's go together. So it's the reciprocal to cosine of theta. And so hence, or note, let me use this green. So note, when plotting the graph of secant, consider the graph of cosine. Okay, so for example, so this is much like the cosecant. So let's plot the graph of, let's do f of theta is equal to simply secant of theta to begin with. So let's consider g of theta equal to cosine of theta. Okay, so of course, in this case, the amplitude is 1, and the period is standard, 2 pi. So theta versus f of theta coordinate axes. Okay, so theta, f of theta, let's do 1, 2, 3, 4 quadrants going forward, and 1, 2, 3, almost 4 going backwards. My amplitude is 1. Okay, so this is 2 pi. Each quadrant is 90 or pi over 2. And the same going in to the left, so minus pi over 2, minus pi, minus 3 pi over 2, and negative 2 pi. So cosine starts at amplitude and is a reflection of itself about the y-axis because it's an even function. So we start at amplitude, go down, down, then back up. So cosine, which is our guide for secant, will look like so. Okay, and much like with cosecant, thou shalt not divide by 0. Let's do it. So wherever cosine goes through 0, I know that the reciprocal function secant will have a vertical asymptote. Thou shalt not divide by 0. And similarly, if I now plot f of theta is secant of theta, the reciprocal to 1 is 1. The reciprocal to negative 1 is negative 1. So they meet at the peaks and the troughs, and they approach the asymptotes asymptotically. And remember, you can never cross a vertical asymptote when plotting, if it's a function, right? So there we are. Okay, so this is the standard secant plot. Let's note what the domain is. So let's note the domain excludes all values of theta for which cosine is 0. That is, the denominator of secant is 0, so the domain will include all values of theta given that theta is not equal to, well, it looks like pi over 2, then the distance between pi over 2 and the next vertical asymptote is pi units. So pi over 2 plus pi k, where k is any integer, positive and negative. So I must exclude those values in my domain. Okay, the range. I notice that the range goes from -1 all the way downwards. So the first set will be from -infinite to -1 inclusive. Then I skip up to +1, and my values for y on the graph of secant go upwards from there. So I union that with the set from 1 to infinity. Now remember, this is the range of secant excludes the range of cosine. That is, it excludes the region from -1 to 1. Okay, so let's do 2 more examples. So for example, let's plot the graph. Let's plot f of theta is equal to 2 secant of, let's do 7 theta. I haven't used 7 before. Okay, so let's consider the graph of the reciprocal function. So in this case, actually let me do this in a darker blue. Let's do g of theta is 2 cosine of 7 theta. So in this case, the amplitude is 2, but the period is 2 pi over 7. Okay, so theta versus f of theta coordinate axes. Theta versus f of theta. Theta is the horizontal, f of theta vertical. So we have 1, 2, 3, 4 parts going forward, and 1, 2, 3, 4 parts going backwards. My amplitude is 2. Okay, so this is 2 pi divided by 7, and pi over 2 divided by 7, then pi divided by 7, then 3 pi over 2 divided by 7. So going backwards, these correspond to negative pi over 14, negative pi over 7, negative 3 pi over 14, and negative 2 pi over 7. Okay, so cosine, which we're using as a guide, starts at amplitude and is symmetric on either side of the y-axis. So he goes downhill, downhill, then uphill. So cosine looks like so. Okay, and remember, thou shalt not divide by 0, so wherever cosine goes through 0, the reciprocal function secant will have a vertical asymptote. That is, these are the values of theta which are excluded from the domain of secant. Okay, now plotting f of theta being equal to 2 secant of 7 theta. Oh, gotta move that over a bit. Let me rewrite that. So f of theta equal to 2 secant of 7 theta meets cosine at the peaks and the troughs. And remember, I'm only taking the reciprocal of cosine, not 2, so it still has a height of 2. So we approach the asymptotes asymptotically from each peak and or trough. Okay, so for this function, the domain, let me go ahead and put this down here. The domain was all values of theta, given that theta was not equal to, looks like pi over 14 plus, so what's the distance between each asymptote? That looks like it's pi over 7, so plus pi over 7 times k, where k is an integer. The range goes from negative infinite all the way up to negative 2 on the negative y-axis, inclusive there, and then starts again at positive 2 on the y-axis, goes all the way up to the infinite, so including 2 all the way up to the infinite. Okay, so one more for good measure, shall we? So for example, let's plot f of theta is equal to negative 3. No, did I use 3? Let's do negative 4 secant of 3 theta. Let's do it that way. Okay, so I'm going to consider g of theta being equal to negative 4 cosine of 3 theta. So I know in this case that the amplitude, which is distance, is positive 4. The period is 2 pi divided by 3. And now because of this negative, it has x-axis reflection. Okay, so theta versus f of theta coordinate axes. Let's see. Let's go here. Theta versus f of theta. Let's break this up into 1, 2, 3, 4 parts going forward, and 1, 2, 3, 4 parts going backwards. What was my amplitude again? 4. Let's do 1, 2, 3, 4, and negative 1, 2, 3, 4. So I know I have 2 pi divided by the coefficient 3 inside the argument there. I have my pi over 2 divided by 3. I have pi divided by 3. I have 3 pi over 2 divided by 3. And these going left simplify to negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3 respectively. I know cosine usually starts at amplitude, but since this would be negative, he's going to start at negative amplitude and be symmetric with respect to the y-axis. Okay, so this is what cosine would look like if we were to plot him. But remember, we're not. We're plotting this as a guide to secant. Okay, so once again, wherever the graph of cosine goes through 0 is a vertical asymptote to the graph of secant. And I think I used a different color on the other graph. Sorry about that. It was a brighter red. Okay, so now let's consider f of theta being that which I want to plot, which is minus 4 secant of 3 theta. So peaks and the troughs, they meet at the peaks and the troughs. and go off towards the asymptotes asymptotically, or approach them asymptotically. That's not very good. No, not drawn very well. Okay, so what is the domain and range here? Let's look at the domain. What are the exclusions to theta? Well, the asymptotes, right? So I know that theta cannot be pi over 6. And what's the distance between two vertical asymptotes? Looks like that's the distance of pi over 3. So plus any multiple, any integer multiple of pi over 3. Plus or minus, right? Those must be excluded. It's a terrible integer symbol. Let me redraw that. Okay, and the range? The range, once again, goes from -4 to -infinite. So from bottommost value, -infinite, going upwards on the y to -4, inclusive there. Then I start again at 4 and go off towards the infinite. So union the set from 4 to the infinite, non-inclusive.